Okay, this is scenario 3 for chi-square test of independence. This is page 228 of your notes. This was also a released AP question. You can see that it was a 2003 question number 5. So a random sample of 200 students was selected from a large college. Nice of them to tell us it's a random sample. That's a good start. In the United States, each selected student was asked to give his or her opinion about the following. The most important quality of a person who aspires to be president of the United States is knowledge of foreign affairs. I think some people thought that was domestic affairs, and Clinton thought he was really good at that. So each response was recorded in one of 5 categories. The gender of each selected student was noted. And so right here we have multiple categories, and I sit there and go, you know what? Multiple categories, multiple rows and columns, chi-squared test of some sort. For sure, what it is, don't know yet, but it's a chi-square test. Is there sufficient evidence to indicate that the response is dependent? Oh, there's one of those key words that tells me it's a chi-square test of independence. All right, so we know it's a chi-square test of independence. We know degrees of freedom for something like this is going to be row minus 1 times column minus 1. So in this case, we have 2 rows. 2 minus 1 is 1. And 1, 2, 3, 4, 5 columns. 5 minus 1 is 4. When we multiply 1 times 4 is 4. So our degrees of freedom in this case is 4. So we need to start off by writing our null and alternative hypothesis. Response and gender are independent. So null hypothesis. Response and gender are independent. Please remember, R is the same as saying equal. It is, all right? Note to self, if they are independent, they are not associated. HA, response and gender are not independent. Are not is the same as saying not equal. That's why we like to do it this way, which means if they're not independent, the note to ourselves is they are associated. Conditions. First condition is random sample, and they told us that. So that was given. Number 2, 200 divided by 0.1 equals 2,000. They told us it's a large college, reasonable to assume that there are at least 2,000 students. Further, N is less than 10% of the population. Pop. Number 3, expected values greater than 5, see table. I really should put the word all in front. All expected values greater than, it says see table. I'll come back and do that one in just a moment. Let's go ahead and get the last one done. The last one is counted data. All values are counted data. Counted / whole numbers. Number data, okay. And we know that because that's a whole number, that's the whole number, that's a whole number. Whenever they give us a table, we should go ahead and total everything. So I'm going to do that. So this is 30, this is 40, this is 40 as well, same thing, 50, and this right here is 40. And make sure I have this correct because it wouldn't be the first time that I messed it up. 30 plus 40 plus 40 plus 50 plus 40 better equal 200. It does. Like, how did I know it equaled 200? Because they told me so. They told me up here that there was 200 students. If I add these up, I end up getting 90, and this adds up to 110. Everything, oops, not 111, 110. Great. So I need to do the expected values. Well, remember, I can go 30 times 90 divided by 200. So let's do that real quickly because I can do that for every single one of them. 30 times 90 divided by 200. And that gives me 13.5. So I'm expecting 13.5. But the quick way to do that is to to enter the matrix. All right. How cool is that? So we have 1, 2 rows and 1, 2, 3, 4, 5 columns. So 2 by 5. 10, 15, 25, 20, oops, that's not right. 10, 15, 25, and then 25 again. Then 20, then 25, and 25, and 25, and 15. And let's go ahead, now that I've done that, we're going to go second quit. And we're going to go ahead and run the entire test, even though we're still looking for expected values. All right, even though we're still looking for expected values, we're going to run the whole test. Stat test, chi-squared test. And we're going to write down our what we ended up with. And what we ended up with is I ended up getting a chi-squared value of 8.922. P-value, P equals 0.063. Degrees of freedom is what we calculated by hand was 4. All right, so wrote that down. Let's re-enter the matrix again. So we're going to go back into our matrix. So second matrix, edit, drop down into B. And sure enough, there's 13.5. So here's what we have. 13.5, and then we have 16.5. We have 18, we have 22, we have 18, we have 22, we have 22.5, we have 27.5, and then we have 18, and we have 22. All right, so that's our matrix. Great. I look at these and I see some decimals, but decimals are fine for expected, not okay for observed, but fine for expected. And every single one of those is greater than 5, so we're good to go. All right, so we've done that. We can go ahead and set up and run our test. So we're going to write a formula. Our formula is going to be chi-squared equals observed minus expected squared over expected. Really important you write your formulas down. If you write your formulas down, you don't have to name the test, which means you don't have to worry about the verbiage being wrong or right. So write your formulas down. All right, just do it every single time. Otherwise, you have to name the test, and if you name it incorrectly, you lose points. Write the formula, good to go. So writing our formula, So I observed 10. So 10 minus my expected 13.5 squared over 13.5 plus dot, 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 plus, because we're doing the bookends. And then we have 15 minus 22 squared over 22. When we ran this thing, and I'm still going to rerun it again, even though I wrote it down, I went stat test, chi-squared test, and I got 8.922. That means I have a p-value. P-value is 0.063. Alpha 0.05. This is greater than. So we fail to reject the null. So that's our decision. Then we need to go ahead and write our conclusion out, and our conclusion is going to be our p-value is 0.063. We fail to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that response and gender are not independent. Okay. And remember, as always, this part right here comes straight from HA. Response and gender are not independent, straight from HA. And it's always like that. Every single one of our, we set it up that way. So what's our simplified? Well, we cannot say response and gender are related. Or we cannot say that response and gender are associated. They might be, but we can't say it based on our test, not at an alpha 0.05. All right, not at an alpha level of 0.05. We can't say that. All right, thank you. And that's all of the chi-square test of independence. Next ones will be chi-square test of homogeneity.